one of the first things I observed was, what I looked for was what was the minimum number of prime components, and within the what was the minimum value of the prime factors and the minimum value of their exponents that would get me an abundancy of over 3. So let me just kind of populate just some numbers here in the input. This just gives me some basic input. There's 10 prime components, and let me run this. And when I run this, it will calculate all of these properties for that number in just specified here in its prime factorization. And I was really more focused on this number here. And if I just go ahead and add, I have all the betas set to 1, which makes this not eligible to be an OPN, but I wasn't really looking at that at the time. But as I did earlier, I'm going to add on some prime factors until that abundancy reaches 3. And so we can see that it's a total number of 16 prime components with 5 and 3 being in there. 7 is skipped, and then the rest of them are consecutive from 11 to 61. So a minimum of 16 prime components with all of their minimum values for the exponents is what is needed for this abundancy to be over 3. Now, if I wanted to see if I can reduce the total number of prime components, what I did was I just changed one of these betas to 2, and I determined that beta 1 is the best one to change. So I change it to 2, and then I'm going to reduce the number of prime components. If I go back to 14 or 15, 14 Qs, then it's still over 3. If I go to 13, it's still over 3, barely. And so if I set this to 12, it will drop below 3. So 13 Qs or 14 prime components is the minimum to have an abundance over 3. And there it is.